Features of object storage services in Bluemix. In this section, we'll discuss the key characteristics of object storage services in Bluemix. Cloud computing has been the go-to strategy for many businesses around the world. Among the many cloud services cloud computing provides, object storage has perhaps experienced the most growth in recent years. But what exactly is object storage? Object storage is an electronic storage which is highly scalable, easy to use, cost-effective, and has a huge capacity to be distributed across regions and even countries. It is commonly used for storing pictures, documents, audio, video, system backups, and database dumps. Every day, people create new applications based on object storage. Object storage has become the backbone and service in cloud computing. Obviously, you can't store a shoebox in object storage, even though you can save a picture in the shoebox in object storage. People often confuse object storage with other popular storage systems. A database is not considered object storage, for example. A database cares about the data and the data structure. Designing a schema for the data to be saved in is probably the most critical task a database application designer has to do. But for object storage application designers, data structure is less important. Object storage itself cares very little about how the data is structured. Block storage often provides a raw disk space for client applications to create file systems and then store data in the file system. The application is very much in the business of managing the file system. On the contrary, object storage client applications do not really care about the underlying file systems. It only cares that an object is sent to the object storage and persisted for later use. Object storage differs in two ways in comparison to a file system. First, object storage often has a flat structure where an application can create a container, then place an object inside that container. File systems, on the other hand, can allow unlimited container nesting. That is, you can create many levels of containers or folders. Second, the method to manipulate objects in object storage is HTTP request, which is more internet friendly. The method to manage objects in a file system is more local oriented and is located where the application runs. IBM Object Storage for Bluemix version 1 provides storage that can be bound to a Bluemix application and is sustainable for the use within Bluemix boilerplates. Use this version if you require binding to Bluemix applications with no user interaction required. IBM Object Storage for Bluemix version 1 is based on soft layer storage using OpenStack Swift APIs. It creates an individual Swift account for each user to the Bluemix application to which it is bound. IBM Object Storage for Bluemix version 2 provides a flexible usage model to allow the use of object storage on IBM on-premises private clouds or the IBM public cloud. It uses OpenStack Keystone for authentication and is accessed directly using OpenStack Swift API calls. Use this version if you wish to use object storage from outside a Bluemix application, for example from a virtual machine or a container, or if you wish to use object storage that resides in your private cloud. IBM Object Storage for Bluemix version 2 provides secure connectivity to private clouds, allowing a user with an account on the cloud to securely access the object storage APIs from outside the firewall. When using the IBM public cloud, IBM Object Storage for Bluemix version 2 will create a public cloud tenant and Swift account per Bluemix organization. In addition to traditional enterprise class storage technology, many organizations now have a variety of storage needs with varying performance and price requirements. OpenStack has support for both object storage and block storage with many deployment options for each, depending on the use case. Object storage is ideal for cost-effective, scale-out storage. It provides a fully distributed API-accessible storage platform that can be integrated directly into applications or used for backup, archiving, and data retention. Block storage allows block devices to be exposed and connected to compute instances for expanded storage, better performance and integration with enterprise storage platforms such as NetApp, Nexenta, and SolidFire. OpenStack storage uses containers to group files. They are much like folders in a traditional file systems, but cannot be nested. Storage is also accessed using a REST API using the HTTP verbs get, push, and delete. The CAP theorem identifies three distinct concerns: consistency, availability, and partition tolerance. In consistency, all clients see the data, even with current updates. With availability, all clients are able to access some version of the data. Using partition tolerance, the data can be split over multiple servers. Object storage capabilities. OpenStack provides redundant, scalable object storage using clusters of standardized servers capable of storing petabytes of data. Object storage is not a traditional file system, but rather a distributed storage system for static data such as virtual machine images, photo storage, email storage, backups, and archives. Having no central brain or master point of control provides greater scalability, redundancy, and durability. Objects and files are written to multiple disk drives spread throughout servers in the data center, with the OpenStack software responsible for ensuring data replication and integrity across the cluster. Storage clusters scale horizontally simply by adding new servers. Should a server or hard drive fail, OpenStack replicates its content from another active nodes to new locations in the cluster. Because OpenStack uses software logic to ensure data replication and distribution across different devices, inexpensive commodity hard drives and servers can be used in lieu of more expensive equipment. The Swift object storage architecture provides separate access and capacity tiers that can be scaled separately. The access tier can be scaled for greater concurrency. It is a stateless, shared nothing architecture. The capacity tier handles the actual storage of objects and can be scaled out for greater capacity. Uploads are routed through the load balancer through the capacity tier where multiple copies of the object are written for redundancy. Downloads are also routed through the load balancer, which will direct the request to a single copy of an object in that capacity tier. One of the difficult problems that needs to be solved in a distributed storage system is how to effectively replace the data within the storage cluster. Swift has a unique as possible placement algorithm which ensures that the data is placed efficiently and with as much protection from hardware failure as possible. Swift replaces data into distinct availability zones to ensure both high durability and high availability. An availability zone is a distinct set of physical hardware with unique failure mode isolation. In a large deployment, availability zones may be defined as unique facilities in a large data center campus. In a single DC deployment, the availability zones may be unique disks in a single node cluster, unique rooms separated by firewalls and powered with different utility providers. A multi-rack cluster may choose to define availability zones as a rack and everything behind the single top of the rack switch. Swift allows a deployer to choose how to define availability zones based on the particular details of the available infrastructure. The object storage system organizes data into hierarchy as follows. Account. This represents the top level of the hierarchy. Your service provider creates your account and you own all resources in that account. The account defines a namespace for containers. A container might have the same name in two different accounts. In the OpenStack environment, account is synonymous with a project or tenant. Container. This defines a namespace for objects. An object with the same name in two different containers represents two different objects. You can create any number of containers within an account. In addition to containing objects, you can also use the container to control access to objects by using the Access Control List, or ACL. You cannot store an ACL with individual objects. In addition, you can configure and control many other features such as object versioning at the container level. You can bulk delete up to 10,000 containers in a single request. You can set a storage policy on a container with predefined names and definitions from your cloud provider. Object. This stores data content, such as documents, images, and so on. You can also store custom metadata with an object. With the Object Storage API, you can store an unlimited number of objects. Each object can be as large as 5 GB, which is the default. You can configure the maximum object size as well. You can also upload and store objects of any size with large object creation, use cross-origin, resource sharing to manage object security, compress files using content encoding metadata, override browser behavior for an object using content disposition metadata, schedule objects for deletion, bulk delete up to 10,000 objects, auto-extract archive files, generate a URL that provides time-limited get access to an object, and upload objects directly to the object storage system from a browser by using the POST middleware. Here's an example of using the API version 1 of the object storage service in Bluemix. Before creating or reading any objects from the service, you must obtain authorization token from the server. This is retrieved from the auth_URI endpoint using basic authentication with the username and password. These credentials are available in vcap_services. Upon successful and PI URL, an access token are returned in the HTTP header. The retrieve token is then used on all subsequent requests that manipulate containers and objects. Creating containers are done via HTTP put. The storage URL and auth token returned from the authentication operation are used in a put operation that also provides the container name. A 201 HTTP code is returned on success. Container metadata is returned via HTTP head. The storage URL and auth token returned from the authentication operation are used in a head operation that also includes the container name. A 204 HTTP code, no content, is returned on success, and the metadata is returned in the HTTP header. Uploading objects are done via an HTTP put. The storage URL and auth token returned from the authentication operation are used in a put operation that also includes the container name in the URL followed by the file name. The contents of the file are included in the request body. A 201 HTTP code is returned on success. Listing containers are done via an HTTP GET. The storage URL and auth token returned from the authentication operation are used in a GET operation that also includes the container name. A parameter indicating the format of their listing can be used. Valid values are JSON, XML, or plain, which is the default. If you use the format XML or JSON, the response shows extended container information serialized in the specific format. If you append the format plain, or don't use the format parameter at all, the response only lists the object names separated by new lines. Downloading files is done via an HTTP GET. The storage URL and auth token returned from the authentication operation are used in a GET operation that also includes the container name in the URL followed by the file name. The contents of the file are returned if the request is successful. Deleting files is done via an HTTP delete. The storage URL and auth token returned from the authentication operation are used in the delete operation that also includes the container name in the URL followed by the file name, similar to the previous examples. A 204 HTTP code is returned on success. Object storage is a scalable, cost-effective file-based system available in the cloud. OpenStack Swift is an object store implementation available in SoftLayer and exposed in Bluemix via two services, Object Storage version 1 and Object Storage version 2. OpenStack Swift has a REST API to support uploading, downloading, and deletion of files. Thank you for watching this short presentation. Please view the lab associated with this section to learn more.